Okay, so now let's look at gradient. So as learned before, there are two types. When the gradient is positive, our graph actually will look a little bit different. When the graph is positive, you see that actually your graph slopes upward from the left to right. And when gradient is negative, your graph will slope downward from the left to the right. Okay, it's quite clear when you look at the two types, you can straight away see whether it's positive or negative. However, the question is, can you put a number to it? Rather than just saying that, oh, this is more steep than the other. Can you actually put a number to it? Define it. Why it is more steep? Okay, are you able to do that? So answer is yes. There is actually a way to do calculation to find out whether a slope is more steep or not. Now let's take a look at the line L1 over here. Okay, if I want to define, I say L1 is more steep than L2. Now how do I know for sure? So one calculation that we can do here is by taking any random 2 points that lies on the line, and then we do a comparison. So from this point 1 to point 2, what happens in the horizontal distance? Okay, we draw a right angle triangle for the 2 points that we want as a reference point. Okay, so we form two reference points, we call it point 1, point 2. Then after that, we compare the differences. From left to right, what is the change in my x? My x increased by 1 unit. And for vertical change, it actually goes up, right? From point 1 to point 2, the graph went up. Went up by how much? I can see that it went up by 3 units. So what? I know that it went, for x-axis, it increased by 1 between these 2 points, and y-axis increased by 3, y-coordinate increased by 3 between these 2 points. So what does it mean? It means that mathematically there is actually a way for us to calculate. And the calculation is this. The gradient is rise over run. Okay, the vertical change divided by the horizontal change. Alright, keep in mind that the gradient do not have unit. So let's say cm, then cm divided by cm. So gradient do not have a unit here. Alright, example 5. Find the gradient of the line L1 and L2. So I'll do L1, you will do L2. Okay, L1. If I were to change or note these 2 points here as my reference point, point 1, point 2, I look at the run. From this point to this point, what is the change here? Okay, I draw a 90-degree triangle, make the two reference point 1, reference point 2. What's the change? It changed by 1.5. And what about the rise? How much did it change? It increased because it went up by how many units? 3. So I get my rise is 3, run is 1.5, answer is 2. What about L2? L2 is something different. I want you guys to try. Okay, I'll pause here. You will try first. You should pause the video and try also. Okay, I hope you guys have tried already. The reference point here is stated. They want these 2 points, draw the right angle triangle, and then measure the change. Now, I want you guys to consider it differently here because they give you the coordinates. Let's look at the x. Because in coordinate, first number is always an x. So the x is actually this. Okay, I draw in blue so you can see. Do you see that the change in my x is actually 6 units? Then you look at the number here. 9 minus 3 is also equals to 6. I take the one later minus the earlier one, my 2 reference point. I minus it for the x value. I get that my run is 6. Do you see that they're related to each other? Now let's look at my y. It's from 1 to 3. It increased. Okay, so 3 minus 1, I get 2. So the change in my rise is 2. So therefore, my gradient is 1 over 3. Okay, example 6. I want you to try to do the same thing, but there is a slight change here. For y, for j to k, the line jk, you choose any 2 points that you want. I will choose this point, and let's say I want a smaller triangle. I choose this point over here, a right angle triangle. In this right angle triangle, I want to measure the change in my x and y. So let's see, over here, what is the change? From left to right hand side, between my 2 reference point here, my x increased by 1 unit. Okay, so my run is 1. What about my rise? Actually, it didn't rise at all. It dropped. From 1 to 2, actually, it went down. It dropped by -2 units. So therefore, my gradient for this is -2. Can you try LM on your own? Okay. Right, I'll pause. You should pause also. Okay, I hope you guys have tried already. For this graph, LM is actually here. Draw a triangle, triangle. Your triangle might be different from mine. You might draw a bigger triangle, which is fine because you would end up with the same answer. And I will compare my reference point 1 and reference point 2. My x value increased by 3 units. Then my y, it actually dropped by 1 unit. So it's -1/3. So answer is just -1/3. Okay. Example 7 will be in the next video. Thank you.